Question 19 and 20 from the homework is similar to the other problem that I posted about draw the best Lewis structure for the carbonic acid and calculate formal charge on carbon. And the next one, draw the best Lewis structure for sulfur tetrafluoride and calculate the formal charge on sulfur. So first things first, we wanted to take in a total account of our valence electrons that we have. So I have 2 hydrogens, I have 1 carbon, and I have 3 oxygens. Hydrogen is 1s1, so I've got 2 electrons total there. Carbon is helium, 2s2, 2p2, for a total of 4 electrons there. And oxygen is also helium, 2s2, 2p4, for a total of 6 electrons there, 3 oxygens, so 6 times 3, 18 total electrons. 18 plus 4 and 2 is 24 electrons that I have to assign. This one's a little bit harder in that we went from normally putting the least electronegative element in the center. That gets a little bit harder now that we have multiple elements. In this case, hydrogen is the least electronegative, but that does not go in the center because hydrogen can only form 1 bond. So I'm going to put carbon in the center because I know carbon can form multiple bonds. I know oxygen can form multiple bonds. So right there are 6 electrons that I've assigned. Oxygen, oxygen, oxygen. And now I've got 2 hydrogens remaining. I'm going to assign hydrogen and a hydrogen. So there's 2 more electrons for each of those bonds. So let's see. I had 24, I used 6 of those, I have 18, and then I used 4 more in the bonds from oxygen to hydrogen, so I've got 14 electrons left. Well, I want to fill the octet for the surrounding atoms, so 1, 2, 3, 4, right, that fills that octet. 1, 2, 3, 4, that fills that octet. And then 1, 2, 3, 4, 5, and 6. So 6 plus 4 here and 4 here is 14. I've assigned all 14 electrons. All right, just to be sure if we have the right Lewis structure or not, let's assign formal charges. Formal charges, group number minus assigned electrons. So for carbon, and let's assign it for oxygen. So for my carbon, I have 1, 2, 3 electrons assigned. And that's a problem because carbon is group 4 and it has 3 electrons assigned. So I should have a charge of +1 on the carbon. Oxygen is group 6. And I take a look at the oxygen, right? Oxygen is group 6. And on this oxygen, I have 1, 2, 3, 4, 5, 6. So that oxygen is perfect. This oxygen, 1, 2, 3, 4, 5, 6. This oxygen is also perfect because 6 minus 6 is 0. This oxygen, however, I have 1, 2, 3, 4, 5, 6, 7 electrons assigned. So 6 minus 7, a -1 charge on this oxygen. That creates a problem for me because I want to minimize charges. And the second problem, if we didn't notice already, we only have, right, we have not filled the octet for carbon. So what do, right? Well, to get rid of that positive charge, all I need to do is take 2 of those electrons from oxygen and share them in the form of a double bond. Now I have a full octet for carbon, and now if I take a look at carbon and oxygen, oxygen is group 6, 1, 2, 3, 4, 5, 6. So 6 minus 6 is 0. Carbon is group 4, 1 electron for each bond, 1, 2, 3, 4. 4 minus 4 is 0. This is clearly a better Lewis structure because none of the atoms are carrying a charge in this Lewis structure. And the formal charge on carbon is 0. For question 20, we've got sulfur tetrafluoride, so let's figure out our valence electrons. We've got sulfur, which is neon, 3s2, 3p4 for 6 electrons, and then I've got fluoride, which is helium, 2s2, 2p5, so 7 valence electrons. and I've got 4 fluorines. So 4 fluorines, 7 valence electrons each. That's 28 valence electrons from fluorine. And I can't forget that negative charge. That negative charge means I'm going to add in 2 more electrons. So that's 36 electrons I need to assign. This one should be a little bit easier. We're going to place the least electronegative element in the center. That's sulfur. And then surround it with the remaining elements. So 1, 2, 3, 4. And those are fluorine. So there's my fluorine, 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 and fluorine. I just assigned 8 electrons. So 36 electrons minus 8 electrons. I've got 28 electrons remaining. I'm going to fill the octet for sulfur, right? Each of the sulfurs only has 2 electrons. They want a total of 8. So 1, 2, there's 6 assigned there, plus 6 more assigned here, right? Now giving a total of 8 to both of those fluorines. So that's 12. This is 18. This is 24. So I've assigned 24 electrons. I've got 4 electrons remaining. Where should I put those electrons? Well, following our rules of making these Lewis structures, we should place those electrons on the central atom. So 1, 2, 3, and 4. No electrons remaining, and I've assigned all the electrons I have to work with. I did violate the octet rule for sulfur, but that's fine because sulfur is in the 3rd row of the periodic table. It has access to d orbitals. So that way it can accept more than 8 electrons, as many as 12 electrons. Now I need to assign my charge for sulfur. Sulfur is group 6. Taking a look at the assigned electrons, 1 electron for each bond. So 1, 2, 3, 4. And then all electrons in lone pairs. So 5, 6, 7, 8. So 6 minus 8 is minus 2, right? And that makes sense because overall the charge on the molecule was minus 2. Our fluorines are neutral, so that negative 2 charge has to be carried somewhere. That negative 2 was carried on the sulfur. So by following the rules that we know, determining the total number of valence electrons, placing those valence electrons, filling the octet, and then checking, did I fill the octet? Did I break the octet rule? And checking the formal charge, we should be able to know, do I have the best Lewis structure or not?